So in this video today, we're going to look at the addition and subtraction formula for trigonometric functions. So let's see what we have. So we're given that tangent to A equals -5, and we're asked to find tangent of 2A. So we're going to use one of these double angle formulas. So in particular, tangent to x equals 2 times tangent of x over 1 minus tan squared x. In our case, x equals a. So let's just plug directly into this formula. Tangent of 2a equals 2 times tan a, 1 minus over 1 minus tan squared a. We know that tangent a equals -5, so we're going to plug that in wherever we see tangent a. And then we're going to evaluate. So we have 2 times -5 is -10. 1 minus -5 squared is 1 minus 25. So we end up with 10 over -24, or 5 over 12. Cool. All right, so let's see what we have next. So we're asked to show that tan 2 theta equals 2 times sine theta times cos theta. Okay, so for this question, we need to use our sine formula for the addition of two angles. So sine x plus y equals sine x times cos y plus sine y times sine x times cos y. There you go. So in our case, x equals y equals theta. So let's start with we'll indicate this by star. So let's start with the left-hand side of star. We're going to look at sine 2 theta. So if we plug into our double star formula here, we have that sine 2 theta equals sine theta times cos theta plus sine theta times cos theta. That just equals 2 sine theta cos theta, which equals the right-hand side of our star, which is what we were looking to show. That wasn't too difficult. Okay, so now let's look at our next problem. So now we're asked to find the cosine of 5 pi over 12. So of course we're considering radians. So what we're going to do here is we're going to try and write 5 pi over 12 as the sum of two of our special angles, or at least two of our special angles, or some combination of our special angles. So let's have a look. So 5 pi over 12, it actually can be written as pi over 6 plus pi over 4, right? So let's have a look and check that this is correct. So if we, how about we do it this way? So we'll just do a little check on the side. Well, let's start with pi over 6 plus pi over 4. Need to put everything over a common denominator. The common denominator is 6 times 4, which is 24. So we have 10 pi over 24, or 5 pi over 12, exactly what we were looking for. All right, so now that we know that we can write 5 pi over 12 as pi over 6 plus 4, what we're going to do is use one of our formulas for addition for cosine. So which formula are we going to use? Let's have a look. Let's write it up here. So we're going to use cos x plus y equals cos x times cos y minus sine x times sine y. All right. So in our case, we are going to take x to be pi over 6 and y to be pi over 4. So now we're just going to substitute into this expression here. We'll call it triple star. Right, so cos 5 pi over 12 is the same as cos of pi over 6 plus pi over 4. Now we're going to apply our triple star formula, and we get cos of pi over 6 times cos of pi over 4 minus sine pi over 6 times sine of pi over 4. Okay, so now we need to find the cosine and sines of pi over 6 and pi over 4. So this now brings us to our special triangles. So let's draw special triangles out right here. We got two of them. We have the one where our angles are pi over 4 in the corner, a right angle triangle. And then we indicate the lengths of our sides as 1, 1, and hypotenuse root 2. Our second special triangle, 90, pi over 3, pi over 6. Our sides are 1, root 3, and 2. From these triangles, we have that cos pi over 6 is root 3 over 2. Cos of pi over 4 is 1 over root 2. Minus sine of pi over 6 is 1 over 2. And sine of pi over 4 is 1 over root 2. You can write everything over a common denominator. We have root 3 minus 1 over 2 root 2 as a cosine of 5 pi over 12. Good. And one last question. Okay, so we have find the tangent of 105 degrees. So again, we're going to try and write 105 degrees as a sum or difference of combinations of some sort of linear combination of our special angles. Well, this isn't too bad. So 105 degrees can actually be written as 60 plus 45. That's pretty simple. So now what we have to do is we have to find a formula for tan x plus y. And that's not too difficult. This is tan x plus tan y over 1 plus tan x. 1 minus tan x times tan y. Right? So in our case, x is 60 and y is 45. So let's apply this formula and plug in our x and y values. So tan, let's write it over here, tan 105 equals tangent of 60 plus 45. And this equals, let's make this a little smaller so I can see everything on the screen. Okay. All right, so now we're going to plug into our formula for tan x plus y. We have tangent of 60 degrees plus tangent 45 degrees all over 1 minus tangent 60 times tangent 45. So now we go back to our special triangles, which are just above. All right, so 60 degrees is the same as pi over 3 radians. Tangent of 60 degrees is, what is that, root 3 over 1. Let's see, plus tangent of 45 degrees is 1. 1 minus tangent of 60 degrees, again, is root 3 over 1 times tangent of 45 degrees is 1. So if we simplify this, we have root 3 plus 1 over 1 minus root 3. That brings us to the end of our session today. If you have any questions, give us a shout at info@raisemymarks.com or give us a call day or evening. We look forward to hearing from you. Thank you for watching.